Hello students, so let's talk about nucleophilic substitution reaction SN1, substitution nucleophilic unimolecular reaction. Now what is that reaction? This reaction is take place in polar protic solvent. Now what is polar protic solvent? So before we jump into the reaction, first we look into the types of solvent, right? So there are two types of solvent, as you can see. There are two types of solvent. The first one is polar solvent, another is non-polar solvent. Okay, here you can see the polar solvent and non-polar solvent. Non-polar solvents like carbon tetrachloride, benzene, diethyl ether, they are non-polar solvent. Okay, and on the other hand, if we look into the polar solvent again categorized into two categories. The first one is polar protic solvent, which is represented by PP, polar protic. What are polar protic solvent? Which gives protons or H plus ions, right? Say for example, water, ROH, RCOH, yani water, alcohol, acid, acetic acid. They are polar protic solvent because they give H plus ions or protons. On the other hand, if we look into the polar aprotic solvent, which is represented by Pa. Okay, so polar aprotic solvent which does not gives H plus ions or protons. Okay, got it? Now say for example acetone, dimethyl sulfide, dimethyl formamide, dimethyl acetamide. So sometimes the structure of these compound will be asked. Now you see, this is acetone, right? CO group is there. In acetone, if you replace O then by S, then you will get dimethyl sulfide. Okay, dimethyl sulfide. And here you can see, if in acetone you put one CS3, then you will get dimethyl acetamide, right? And if you replace this CS3 by H and NH2 group is there, so it is dimethyl formamide, right? So these are the example and their structure of types of solvent. Now come to the main part of this reaction, that is SN1 reaction. Now in SN1 reaction, what is happening? We have taken the example of tertiary butyl bromide. Tertiary carbon is there, three sides carbon is attached. This carbon is attached with three other carbon from three sides. So what has happened here? You can see the shared electron is shifted toward the bromine atom. Why? Because bromine is halogen and halogen have the more electronegativity than the carbon. So the shared electron will shift toward the bromine, and in that way the bromine will detach from the substrate. This is substrate. What is substrate name? Tertiary butyl bromide. Okay, and this is very slow step. Because this is very slow step, so this is rate determining step also. Now after leaving this group of bromide, right, what will happen? The carbon will carry the positive charge, right? These three methyl group is there and the carbon carry the positive charge. When the carbon carry the positive charge, it is called carbocation. So in the first step, the carbocation is formed, right? And in the next step, what will happen? The OH, which is a nucleophile, okay, this OH will have choice. Now from where this OH group comes? Because we are studying the reaction of RX plus ROH, alcohol या वाटर या अल्कोहल से ये न्यूक्लियोफाइल हमारा OH आ गया. ओके, नाउ इट हैज ऑप्शन to attach with the carbon of carbocation from two sides, either from the front side or from the back side. If it attached from the back side, you can see here, right? So it will rotate the plane polarized right into anti-clockwise. right? And if it is attached from the front side, then it will rotate the plane polarized light into the right side clockwise. So the mixture of two compound will be obtained. Okay, and what is the structure of this carbocation? This is sp2 trigonal planar. Okay, so clockwise and anti-clockwise, two type of compound we will get. This is called racemic mixture. What it is called? Racemic mixture. What is racemic mixture? A mixture which is optically inactive. Why it is optically inactive? Because see, clockwise and anti-clockwise, both they cancel their effect of plane polarized light. So such type of mixture is called racemic mixture. Okay, now come to the conclusion of this reaction. So what has happened? This is two-step reaction. The first step is slow and second step is fast. In the first step, carbocation is formed in very slow manner, and that is why it is a rate determining step. And we will get the racemic mixture of tertiary butyl alcohol. This is the racemic mixture. What is racemic mixture? Which is optically inactive. Why it is optically inactive? Because it cancels the effect of plane polarized light. This is first order reaction, and its molecularity is 1, because one molecule is involving in the reaction, so its molecularity will be 1. Okay, and it is first order reaction, already I have told you, and the rate of reaction will be depending upon the Rx. Why? Because the concentration, if the concentration of Rx is more, then what will happen? The more product will be formed. If the concentration of Rx is less, then less product will be formed. So that is how SN1 reaction will be taking place.